All right, guys, welcome along. So today we're going to use this factorizing tool, and this should be one we're pretty much familiar with. But while we've been expanding up to now, I appreciate that to make this step to factorizing, you have to be willing to move your thinking forward and to apply what you know already, and that is higher order learning. Let's give it a spin. Here, it's up to us to recognize this as being the output from something we were doing earlier in the week. It's a monic quadratic. That means it's going to be an x minus and an x minus, because the middle is minus and the end is plus. So we need two numbers that multiply to 4 and add to 4, 2 and 2. Okay, so in goes, well, except they need to be both negative, so we need to go -2 and -2. Okay. We will write down our answer. This came up today in class. We have the factorizing frame with x minus 2 on the top and x minus 2 on the bottom. That means our answer is x minus 2 times x minus 2. Yes, that can be simplified to x minus 2 squared. Are we correct? And we'll be talking specially about these perfect squares in a separate lesson. And we are. Okay. We move on to the next question. Are there two positive numbers that multiply to 11 and add to 12? Well, this is one of the examples we did for ages and ages and ages, 11 and 1. Having said that, this is an application of our prior knowledge. So I know that that's expecting a part of mathematical thinking or a skill, a strategy, that's a step up from what we know already. That's why I'm making this video for you. We check if we're correct, and now my score is 2 out of 2. This is negative scoring. If you get one wrong, you go down. This we haven't really done, but let me knock ourselves out and say that when the signs are different, it's a mixed sign, and what we're trying to do is to get two numbers that multiply to 11, subtract to 10, and of course they're 11 and 1. But because we're in a mixed situation, a mixed sign, we must take the dominant of the numbers 11 and 1. The dominant one is 11 and give it this sign. So it's going to be -11. And it's going to be +1. Okay, our frame is complete. If we were doing the cross product here, as spoken about in class today, we would have 1x here and -11x here, and we'd make it very clear which diagonal, which cross product it belongs to. -11x. Okay, and +x, as written here. Okay, they chose to write them at the end. We might adopt this, it might be clearer. However, we were giving space here for the x squared. We might adopt that and push it over here and here. We'll see. Answer goes like that, and we check it and it's correct. Okay. Now we're on the plus here tells you these are same sign. Same sign. Whatever signs we're going to use, they're both going to be the same. They're both going to be negative. Because if they were both positive, this would be positive. So they're both negative. Two numbers multiply to 12, add to 7. Well, it's not 6 and 2. It's 3 and 4. Both negative. Okay, so our answer is x minus 3, the top of the frame, times x minus 4, the bottom of the frame. Check your answer. Of course, we're right. We're up to a score of 4. Two numbers multiply to 9 and add to 6. That'll be 3 and 3. Seven and 1. Okay, and you're probably thinking, well, it's pretty easy. 3 and 1. I can't push it on. I have to fill it in, unfortunately. Okay, haven't done it until next week, but two numbers multiply to 8. And now this is where I'm letting the operations be operations and not be part of the number. So we're only dealing with positive integers, and these are operations. It's an operation. That's an operation. I want two numbers to multiply to 8 and to have an absolute difference of 2. 4 and 2. I want the big one to be dictated to its sign by this -4, +2. That's to next week's lesson, if you like. -4, +2. Anyway, I'm going to keep going because you're able to opt out of this video whenever you want to, but I'm going to keep going up to level 2. Okay, now we have primes at both ends. You know, if there's primes at both ends, it's going to be one of the tricks. Is it a sum? It's a sum middle. It's a sum middle. That means the 11 and the 5 stay together. Go through it in first principle and figure out why, and out all our examples we've figured that one out. Okay, get cross product here to be 11. The cross product, as it is shown here. The cross product here is 5x. We talked about cross products, the cross of two different types of thing, the cross of an x with a number. 11 and 2. Come on, these are brilliant, 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 perfect for us. Okay, and we're on level 2. And it's all positives the whole way through. We love it. It's perfect. What's going on? Well, first of all, this ain't prime, so it doesn't. I can already see it doesn't fit either. I know I'm splitting it, but you can't split the 11, so that's a shoe in, yeah. And therefore x is a shoe in. Okay, so our x's have to be the prime number 11x, the prime number of x's, and so on. So now we're splitting to 12. Trial and error will do fine, but let me say this. I can't possibly use 6 and 2 because that would be an even and an even cross product, and two evens don't add to an even, not an odd. So it's going to have to be an odd and an even, and I probably have them the wrong way around. That won't bother me at all. 33 and 4 isn't going to hack it. Swap them. Let's see where we go. Now we've 44 and 3. Okay, so there was another strategy or another layer of logic came into it there in terms of a thing called parity. Parity is to do with the oddness and evenness. Okay, so you couldn't have two evens here and expect to get an odd here. Similarly, you couldn't have two multiples of 3 here and expect to get anything but a multiple of 3 here. But it's most handy for thinking in terms of evenness and oddness. Okay, we're still on level 2. 7 eighths, 56. Product is no good. 7 plus 8 is 15. No good. I know I have to split the 8. I know I'm going even, and there's no other way to split the 8, only 4 and 2. However, once I've done that, 4 and 2 does matter what way it goes. Well, if 4 sevens, then you can think magnitude. And go, well, 4 sevens is 28, getting me close to 30. That sounds good, and it is good. Okay, go the other way, and you just won't get yourself to 30. These are both prime. Now, that'll be a product. They're not prime. Sorry, that's not a prime. And indeed, I do have to split the 2. So I'll just do this one, even though it's probably we're going to do a bit of expanding to get really familiar with the behavior here. Well, I already know it's 2 and 2. And because it's going to be 2 and 2, I'm not going to need, well, one is going to be positive and one is going to be negative. Actually, at that note, it does matter what way to go. So I've picked the right natural numbers, but I haven't picked the right sign distribution. Because the dominant cross product has to match the linear. Now that's an important thing we're going to be talking about. That's an absolute gem. The dominant cross product, the bigger of the cross products, ignoring the signs, has to match in its sign the middle term of the trinomial. Okay, we'll go up to level 3 to see what horrors meet us up here. 8 take 3 is 5. Because just like adding, when we get to a negative here, we're going to see that it'll be a subtraction. I think we'd mentioned it today. So 8 takes 3. That means I'm expecting not to have to split the 8. Okay. Now if I put 3 here, my cross product will be way too big, so I have to put the 3 here. But hold on, one of them has to be negative. We're having a, you see, the negative is recessive, if you like. It doesn't really contribute much here. So that'll make this the negative, won't it? Okay, perfect. And we're going to be splitting to 12. I'll do that now very quickly. Can't split it evenly because then this would be even, so it has to split it with an odd. One of the factors has to be odd. We'll keep that 3ness on its own because it's 2 by 2 by 3, so the 3ness has to be on its own. The 4 can be there. The 11 is 11, but where do we want it? We want it to be 33 and 4, lovely. We'll put it here. Okay. So the fact that it's a prime makes things really easy for us. Are we happy with this? 33 and 4 is 37. Yes, that's fantastic. Okay, that'll do you. Okay, that was 11 minutes of a video, but probably worth watching. You can slow it down, do loads of examples. See you in the next one. See if I'm right. Of course I'm right. You know I'm right. Look, I can't do any more. Come on. It's tempting. Okay, this is for extra. We got 17 is prime. It's 27, no good. 170 and 1, no way. Jose has to be 5 and 2. It doesn't matter what way we put it because the other thing is going to sort it. 2 17s is the way it has to be. Okay, extra for you for free. Bye bye.